Have you ever gone looking for data to support a project, research a security incident, or ways to reduce operating costs? Only to realize that data is fragmented across several locations, like in AWS S3 buckets? Hi, my name is Mark Snyder, and I am a technical marketing engineer here at Splunk. Today I'm going to walk you through Splunk's Federated Search for AWS S3. What I'm going to show you is how Splunk Cloud queries CloudTrail logs, VPC flow logs, customer-managed AWS glue tables, where data is siloed or locked in AWS S3 buckets. I am going to show you how we can access that data directly from S3 without ingesting the data locally, how we can search that data, and even enrich that data with other data resources. The important thing to understand is that Splunk is not taking ownership of your data. Instead, Splunk is being granted controlled, read-only access to that data and remains fully governed inside your AWS account. The AWS Glue permissions allow Splunk Cloud to discover metadata only. This includes the ability to list databases, read table definitions, and enumerate partitions. Splunk uses this information to understand the schema of your data, where it lives in S3, and how it should be queried. There are two types of AWS Glue tables, Splunk Managed and Customer Managed. Splunk Managed Glue tables are created and maintained by Splunk to provide immediate access to common AWS data sources like CloudTrail and VPC flow logs. They follow AWS best practices, are automatically structured for federated search, and require minimal setup, allowing you to start querying AWS telemetry quickly and consistently. Customer-managed Glue tables, on the other hand, are fully owned and controlled by you. These tables represent your data, such as firewall logs or application telemetry, that already exist in your S3 environment. Splunk accesses these tables through explicit glue tables that you create, allowing you to extend federated search to your own datasets without changing how that data is stored or governed. Together, these two models demonstrate the flexibility of federated search, combining turnkey access to standard AWS data with the ability to securely query customer-specific data, all without ingesting that data into Splunk. Splunk Managed or Customer Managed Glue tables provides the structure and schema awareness, while S3 provides the raw data access, both remaining under your control. This model enables powerful cross-dataset analytics without data duplication, ingestion costs, or changes to existing data ownership. Once these permissions are in place, Splunk Cloud can seamlessly query CloudTrail, VPC flow logs, and customer-managed datasets directly from S3, as if they were native within Splunk's data stores. This use case focuses on threat reporting by correlating known APT infrastructure with AWS VPC flow logs. Following a large-scale zero-day attack, the security team receives a list of high-risk IP addresses associated with malicious activity. Using Splunk Federated Search, analysts compare that threat intelligence against VPC flow logs to determine whether any AWS workloads are communicating with those IPs. The workflow demonstrates how locally stored threat intelligence can be joined with cloud-native network telemetry to identify suspicious traffic patterns. Analysts can quickly see whether APT-related IPs appear as sources, destinations, or both, and summarize the findings by site, account, and region. The result is a concise, actionable threat report that helps identify potential compromised paths and prioritize response without ingesting cloud network data into Splunk. This search pulls AWS VPC flow logs through federated search, then compares both the source and destination IPs against a local threat intelligence file called apt-impacted-sites. It normalizes the IP fields, looks up matches to identify the associated site names, and classifies whether each match appeared as the source, the destination, or both. It then filters to only APT-related flows and summarizes the results by APT IP site, AWS account, and region, calculating event counts, total bytes and packets, and listing the protocols and related IPs. Finally, it sorts the report to prioritize the highest volume APT communication first. This use case demonstrates how Splunk can rapidly apply new threat intelligence to existing telemetry without re-ingesting or restructuring data. Federated Search enables security and observability teams to investigate network activity, enrich cloud telemetry, detect threats, analyze authentication trends, and monitor privileged access from high-risk sources. Together, these examples demonstrated how multiple datasets can be correlated in real time, directly where the data lives. The result is faster insight, reduced data duplication, and a more efficient way to understand what's happening across your AWS environment. My name is Mark Snyder, and I want to thank you for taking the time to learn more about Splunk's Federated Search.